So 5G Technology World, we are at DesignCon in Santa Clara, California, and we are talking with Joy Laskar, who is the president of Maja Systems, and you're doing some very interesting work. Can you tell me about it?
Sure, thank you. So we're Maja Systems, we're a startup here in Silicon Valley. Our focus has been, for years on development of millimeter wave based solutions, both highly integrated IC and also the antenna around that. And what we found as we've gotten more and more customer traction, that one of our differentiators that we've been focused on are antenna technology.
So you're talking about specifically millimeter wave antennas?
Millimeter wave antennas,
okay.
Exactly.
So, and what frequencies?
What we talked about today here at DesignCon is at 60 gigahertz.
60 gigahertz, okay.
We're also announcing parts that will be available at around 40 and also around 18 and near 28 as well. So the key 5G bands, as well as it turns out some of the kind of SATCOM type of bands that are of interest as well.
Okay, some of the SATCOM bands.
Yes.
Okay. So how do you see this? How do you see this technology fitting in with 5G?
Sure. So the way we look at 5G, maybe I'd say two things, right? You certainly have sort of the more publicized types of use cases in terms of cellular handset network based and infrastructure. Yep. We also see, and there's been talk about this too, is like impact in the data world, right, or data connectivity world. Because the fact is that once you can start to move multi-gigabit data rates around, and if you can do that wirelessly, and the attributes which are 5G attributes is high data rate, low delay in the connection. Yep. That in certain cases can become competitive to, let's call it, the traditional wired types of solutions. So there could be either an advantage in throughput or an advantage in cost structure, depending on if we're talking about fiber or cabling or copper.
Where do you see those fitting in data centers or in other applications?
Great question. So we right now are working with customers in what we might call industrial side of things, as well as sensors and automotive and early activity around data center. And the commonality in all of these, sort of the sweet spot that we're seeing, is somewhere between roughly about, actually following Ethernet data rates, right? So somewhere between about 1 and 25 gigabit per second over the air, low delay, not necessarily kilometer types of distance or something like that, but really meters. Meters. Okay. And if you look what the alternative is, or the competition, if you will, it's either I'm drawing fiber, or I start to have a fairly bulky or expensive sort of cabling interconnect. So, for example, we have a situation right now where you have a sensor that might be rotating, is generating a lot of data, and the customers need something because of the rotation and sort of the system yield. They want something that's wireless. But say I want a 10 gigabit wireless interface, and in that context, that maps very well in the type of technology that we build. Okay. Highly integrated radio, compact antenna. Another example, I think that's impacted because of 5G, is at millimeter wave. Historically, if you looked at, say, horn waveguide millimeter wave antenna, and if you talk to typical distributors, if they sell 1,000 of those in a year, that's a lot. Yep. Right. But now, folks are talking about MIMO systems, etc. So we already see, minimum order quantity requests, requests for quotes from a single customer that could be as much as 10,000 units. So that there's an example where the industry, needs a solution that is not each antenna is no longer approaching $1,000, with a horn to coaxial transition, right? And again, that's an example where what we're developing could address something like that.
So your products are actually the radio and the antenna integrated?
Yes, well, I'll qualify that.
Okay.
So yes, we build radio and we build antenna. Okay. In some cases, the customers are taking both together, and in other cases, they're taking the antenna with someone else's radio. Okay. And going forward, really just depends on the use case. So one example is actually in the automotive space, right? If you look at a lot of these autonomous or semi-autonomous vehicles, right? They collect a massive amount of data. A massive meaning, every few days, terabytes of data. Okay. Right. And so one of the issues then is how do you move that data locally, right? How do you offload that data? What the system customers would like is a solution where it's truly wireless, right? So there's no human intervention, et cetera. Minimum kind of data throughputs have to be on the order of 10 gigabit or higher. So that's an example where we're already doing sampling where it's our radio with antenna, and we're developing kind of these unit cell modules that the customers can use. So in that case, our radio and antenna is a good solution for them. In other cases, there's just a variety of ICs coming onto the market, and so we think that actually over time it's going to be just like other use cases, Bluetooth, Wi-Fi. There'll be a variety of call it chipset solutions and will be optimized for different applications. So interestingly, right, on the most recent Google Pixel 4 phone, there's a 60 GHz radar chip for gesture recognition to help facial recognition, right?
Okay.
So I think that's, for example, a pretty big game changer, not only because of the use case, but clearly, that automatically becomes one of the higher volume millimeter wave solutions out there, right?
Okay.
So there's going to be more and more of that type of thing. We're using 5G-like bands or 5G-like characteristics, for applications that we probably haven't even thought of yet.
Okay, very good. Thank you very much.
Sure.
Okay.
Thank you. My pleasure.